Hello and welcome to ironic inspection rule presentation. Uh, I would rather say demonstration. Um, Before continuing, I would like to quickly refresh what is a running inspection. A running inspection is a process when we put into a running node with ironic RAM disk and inspect hardware. Then we send this data back to running inspector service where data is processed and actions could be taken accordingly. So how do we inspect a node? We do this by executing um, ironic, sorry, uh, offense, so like this, offense stack bare metal node inspect, and then providing the node. We can do this both ways, either providing the node name or node UID. For the day, I'm going to use node UID, but just to know that some OpenSec commands need to use UID instead of the name. So I want to inspect the node. I give this command, I give the node name, and execute the command. You don't see, as you see, nothing happens. But is it so? So if you do again node list command, this command will show me all nodes available to me. I can see that this node is in the inspect wait state and it's still part off. What it means is that the node is in the process of being inspected, but since it's still powered off and the RAM disk is not running on the machine and the inspection itself haven't started, only when the node will boot and load the image, inspection could take it. And you will see this here on my right side. I have a snippet to query a running inspector logs. The snippet is simplifying the output just to keep the imported pieces for the demo, so you could have a little bit better time following the example. So now, as you see, here is also there's no output because as mentioned, the inspection, the nodes haven't booted yet, and when will this overall the same? When the node will be when the RAM disk will boot up, the inspection will take over, and we will see the log, it in the logs. So with the magic of video editing, the inspection already finished, and you can see there is some input in the inspection log on the right. We see that introspection successfully finished. So where the logs were stored. Let me just increase, and so that the node was powered off, and yes, this is the one I was looking for, is that our introspection data was stored in this Swift object. So now we can say what we expected. So to do that, we do, let me use the shortcut. This command, OpenStack bare metal introspection data save, and we give the name of the node. So we say we want to inspect this, we want this data of this node. And when you execute this command, we get output that is not really readable. So that's the reason I had this snippet. Basically, JQ, if you don't know it yet, is commutativity that formats JSON to more readable format. So here is our data. It's a JSON format, and here we can see other things about the device, such as information about the network cards, CPU, and architecture. Since I'm making this demonstration on the test environment, I'm using virtual machine. So you see that the CPU of my node that I inspected is created by QEMU, so no surprise there. We have information about data, disks, and etc. etc. For the demonstration, I'm going to use mostly these data types. Properties such as disk size, CPU count, and RAM size. So we have this data. So how can we use it, and where this introspection rules come into? So let me show you how to say it. Let me show how the rule is defined, and let me explain it from there. So here we have a JSON object, which would be defined in the file and would be imported to a running inspector. And we have this main field description, the action we're going to take, and the condition when we're going to take the action. And the way to read it would be, if this is the field that is corresponding to our node, we compare if it's equal to the value we want to check. So you see if our disk size is less than 500, or in this case we check if CPU number is equal to 5. And here you see that I made a note saying make sure that this number is a string. So I want to make sure that when you declare rules, and conditions especially, you're matching not only the size but also the data type of the field that you're going to inspect. For example, if I'm going to inspect CPU, in here our CPU size is 1, but it's not a string, but is a number. Here should be also a number. And the way to read it would be like this. If our node has a feed local GB that is less than 500, we just come from here, and compute size is not equal to 5, we only then take actions which could be different depending on what we want to achieve, and they could be also not one but other actions. And that's the main idea of introspection rules. It is to take actions when the conditions are met. It sounds a bit ironic, I know, because here we expected it to be 500, but with the way we declared, our condition was to expect it was not 500, it was less than 500. Anyway, so with this out of the way, we can see that clear the screen, make some padding in the logs, that right. We have our nodes, and here is some of the properties that we saw before: compute architecture, this size and memory. And we would like to use those architecture rules and and see how they work in practice. So I have defined two example rules. One called rule CPU disk and one rule RAM. So the first rule would be applied when both the local disk size is less than 500 and the CPU count is not equal to 5. So in this case we will fail, and as you can see, this rule should match. Another rule will be applied only if our RAM size is not equal to 248 megabytes, which in this case should not be applied. How to do it in practice? We need to import it. Yes. So we do this executing the following command. Unfortunately, I need to execute it separately. I can import multiple files. So I import the first rule, and now I'm importing the second rule. Like this. And to see what rules I have imported, I execute the following command. Good. So these two commands are loaded, and they will be tested when I'm going to inspect the second time. So let's now inspect again the node dash 0, and this time I will use the flag white, which basically will return my prom only when the inspection will finish. So let's see what we'll get. Here we see that these rules were created in the inspection service and with this description, and this I will talk about scope later. So now the inspection have finished, and here you see in the left I have an inspection failed error saying that CPU allocant this mismatch. So the first rule was applied, and that you can see you can see in logs that our the Z how to say we had this desired outcome. So let me increase this for more readability. I'll quickly skip, and the interesting part is these two lines saying that the rule of CPU and local disk size will be applied, but the rule of RAM size on the node will not be applied because the condition failed. And since the action I'll begin. I'll rephrase it. Since this rule was not applied, however, since this rule was applied and has the fail action, we have this error propagating with the message error CPU local disk mismatch. So we had what we wanted. So now comes the interesting part. As you see, when I was running the inspection command, I didn't specify which rules I would like to apply. And the reason is that any rule that is currently imported will be applied. Meaning that if I have these two rules imported and I'm going to inspect all my nodes, all these 3 nodes, the same rules be applied to each of it. So the problem is, what about if I want to be able to inspect all the nodes simultaneously, but only apply selected rules to selected nodes? And here is this scope field coming into play. If you remember, it was mentioned in the inspector log. So what it means is if rule and the node has the same scope, only then the rule will be applied on the scope. If rule has the scope that doesn't match a node scope, or this node that doesn't have a scope, the rule will not be applied. But if the node has a scope, but the rule does not have any scope, then the rule will be applied. In other words, if rule has no scope, it's a global rule applying to every node being inspected, and if it has scope, only it will be only applied to the matching node. So, to demonstrate this, I need to clean the environment. To do this, I want to set all my nodes in the manageable state. This is the shorthand. This is my handy snippet to preset all of those nodes. I have this problem because I try to set nodes that are already in manageable state, so it's not a big problem. And then we want to execute push command to drop all the imported rules, so we could import a different set of rules. Do this. Oh yes. API said basically API says that the rules were dropped. And now we want to import the rules. First, let me show you about which rules I'm talking. And here I have 3 different rules with checking the same field with almost identical message on fail, which is only different by delivery number. And the interesting part is the scope field, which is also different only by number. So we have rule that will be matching on the scope of delivery _1, delivery rule that will be matching delivery _2, and the scope on the rule that will be matching scope delivery _45. Now we have to set, now we have to set our nodes to have property rule scope. So if I'm gonna show it, let me show you. Yeah, so as you see, these nodes have the following properties, but there is no scope property. We need to set it using this command. Okay, let me find it. Nope. Okay, so I have a snippet that will go through each node and set inspection scope that is equal delivery and the number. So the number, the inspection scope for node 0 will be delivery 0, for node 1 delivery 1, etc. So let me run it. Let me then show the same command, and voila, we see that we have each has the scope, different scope, and our rules and they're not imported, so I need to import them as well. This is my another snippet. Basically, we'll take all the files that starts with delivery underscore and import them. So I have these rules, which will match different scopes, which should be delivery underscore 1, delivery underscore 2, and delivery underscore 45. And here I have nodes that has scopes that is delivery 0, delivery 1, and delivery 2, meaning that these two rules should match, and this one should not, because there's no matching node. Okay, so now is the moment of truth. Let us inspect all the nodes like this. So again, you're going to use this snippet. Automation is always good. And we'll start inspections on all 3 nodes. And we will see, as you see, the inspection starting. You can use the magic of video editing to use time traveling, and now the inspection again. I already have executed nodeless commands to see the status of the nodes, and here you can see that node 1 and node 2 are in inspection failed state, while node 0 is in manageable state. And this is expected because we had the rules with the scope delivery 2 and delivery 1 that apply to these nodes, while delivery 0 there was no such rule, because instead there was delivery underscore for the rule with the scope of delivery underscore 45. So those scopes didn't match, and this is the reason this node had no rules applied to it. Another way to prove it that's what happened is to see the introspection logs, and let's quickly use this node. and check here. And if we go to the end, okay, here this is the part that is the data is stored in Swift object. Here we only processing delivery 1 because this node. Let me delete this. Yes. When it's mad, it's there's 1. So not delivery 2 or etc. or delivery 45. Same will happen if I'm going to use node 2, but if I'm going to use this node, here we are saving again to Swift object, and there was no rules applied. Because otherwise there will be a rule line with rule number 1, rule number 2, and there's not meaning those rules when not even checked for this node. So I hope this clarified some things about the iron inspection rules, and I didn't made it more confusing for you. And hope you like it. Otherwise, please reach to me, and I may answer to any questions you have. Goodbye.